For the first half of the problem of 22, we're trying to determine where the total magnetic field is 0 between these two current carrying wires, one coming out of the board and the other going into the board. So you're going to use your right hand rule. Your thumb is the current direction, your index finger is R, and your middle finger will be the magnetic field. If you start by determining if it's in the middle, you use your thumb out, and then in the middle, and the force is up, and then the same for into the board, to the middle, and up. Therefore, you know that it's not 0 in the middle because the magnetic field is up for both. So it has to be either to the left or the right. So if we test it out, if you do it to the left first, the force is down for this, the magnetic field is down for this one, and the magnetic field is up, so they're in opposite directions. You know it's going to be more to the left because I2 is a larger current than I1. Therefore, with the equation, R has to be smaller underneath I1 to make up for its smaller current.
Bring in the dancing lobster.
Alright, so for the second part of the question, for number 22, it says to determine the location of this point. So we know it's already along this axis. We know it's going to be to the left from Amanda's part of the equation. So we will have this distance be x. And we have our equation already here. This equation determines the magnetic field. Mu is a constant. I is our currents given by the problem already. And we have 2 pi. And R is the distance from the point to the wire. Finding the distance where it will be 0 is simply just plugging in the numbers given to you and then setting them equal to each other. So this is what we have here. This is our first wire, I1, and then this is our second wire, I2, and it gets pretty simple from there. You can cancel out the 2 pi's as well as our mu's, and we are left with 2 over pi over x equals 4 over x plus 0.06. We have x representing distance from the wire, the first wire, and x plus 0.06 to represent the distance to the second wire. And then from here, we just cross multiply. 4x equals, it's kind of hard to write it like this. And then we have, this is actually garbage writing. Our distance to be 0.06 meters. So x is 6 centimeters away from the first wire, and that is where the magnetic field would be 0.